Welcome to NASA Edge.
An inside and outside look at all things NASA.
Hey, we have tower rollback is complete of ULA's Delta II launch vehicle carrying the JPSS-1 or Joint Polar Satellite System spacecraft. Looking forward to the launch at 1:47 a.m. Pacific Standard Time.
Yeah, it's going to be early, but it's going to be fun, I assure you.
I tell you what, let's get this show started. A couple months ago, you had a chance to sit down with Mitch Goldberg, who is the project scientist for JPSS.
Yeah, let's check it out. Mitch, what is the Joint Polar Satellite System?
Well, the Joint Polar Satellite System, which we call JPSS, is NOAA's new generation of operational weather satellites.
Now, last year, we covered the launch of GOES-R. How is JPSS different from GOES?
Well, let me start with GOES-R. GOES-R is a geostationary satellite, so it's at an altitude about 22,000 miles above the equator, and its orbit is moving at the same speed as the rotation of the Earth, so it's always overhead monitoring weather in real time. JPSS is a polar orbiting satellite. It orbits from the North Pole to the South Pole, or the South Pole to the North Pole, at a lower orbit, about 515 miles. And as it's orbiting in that same orbit, the Earth is actually rotating underneath it, and we get global observations. So the global observations from JPSS are critical for weather forecasting. So our primary mission for JPSS is to forecast weather out to 7 days. GOES-R primary mission is to watch weather as it unfolds.
So how are you going to use that scientific data that you get from this polar orbit to do that, to predict weather?
Right now, polar satellite data have been used by numerical weather prediction for years, for the last 20 years. So the information is not totally new. We always had atmospheric sounders. JPSS provides us now with this more advanced capabilities, more advanced observations. And then also the program extends out to 2038, so we have this continuity of critical observations. Now, 85% of all data that goes into weather forecast models come from polar orbiting satellites like JPSS. So it's really a critical data set. So basically the data is processed in this building and it's delivered to the National Centers for Environmental Prediction, and they ingest it right into their weather models, and they basically give updated forecasts. So for example, the Hurricane Irma, if you recall, Tuesday morning, I think it was September 5th, they showed that the forecast would take it Sunday morning right off of Key West. And guess what? That weather forecast was spot on. That 5-day notification, that allowed FEMA to get ready, and state governments to get ready for this major disaster.
Clearly, JPSS does more than just work on weather prediction and forecasting. What are those things that you do beyond that?
So recently we responded to Hurricane Harvey and Irma, and now Maria, with generating flood maps. We used the VAERS imager to generate maps of where flooding took place, and that was very important for FEMA for their recovery efforts.
Is there any example of previous weather prediction that didn't have these polar orbiting satellites, and somehow the data, if we'd had it, maybe we could have benefited from it?
Hurricane Sandy is a really good example. If you recall, that 5-day forecast was pretty accurate. It showed that the hurricane was going to move up the coast and make a left hook right into New Jersey, right, in that area. And the European Center for Medium-Range Weather Forecasting, they did a study after the fact, and they pulled out all the polar orbiting satellite, which means that all those sounder information was unavailable. They reran the forecast, and guess what? The 5-day forecast showed Hurricane Sandy being way out to sea. Way far, like hundreds of miles off the coast, probably 600 miles off the coast. So if that was a scenario that was forecast, people would not have been able to prepare for that event, you know. And in reality, eventually the forecast would be right, but it would probably be more like a 2-day forecast. And you cannot prepare and evacuate people with only 2 days' notice. It takes a long, as a good example was the Irma case. It took a lot of planning to be able to evacuate all these people.
And I guess that's why JPSS is planning is a system and planning satellites far into the future.
Absolutely. So when you think of satellites, each satellite has a design life. It can only last so many years. Some satellites are luckier than others, right? Some will last for 20 years, even though it's designed for 5 years. But this information is so critical to the nation that you can't take those chances. So we have a series of satellites from JPS-1 through JPS-4 that will maintain continuity of these critical observations well into the late 2030s.
And welcome back to NASA Edge. We're joined now by Joe Pica from NOAA's National Weather Service. How you doing, Joe?
Good, Chris. How are you?
You know, Mitch did a great job giving an overview of the JPSS mission. Let's turn our attention now to the user side. How will you use that JPSS data in your daily forecast?
So the JPSS-1 data is really the latest in a line of polar satellites, and they're the backbone of all the information that goes into our global weather prediction models. So that's what is used to provide that 3 to 7 day forecast that we get to the public, to emergency managers, so they can prepare for a landfalling storm, forest fires, tornado outbreaks, whatever it is. The polar satellites are the backbone of that data.
Now, when we look at JPSS, I mean, that's the next generation of polar orbiting satellites. GOES-R, that we talked about a year ago, we had you on our show a year ago, is sort of the next generation of geostationary satellites. So how does JPSS and GOES work together and get the data that you need?
So both GOES and JPSS are complementary type satellites. So the geostationary is at 22,000 miles above the Earth, and it stays in a constant place to basically look over and maintain watch on the weather, what's coming right now. Where the polar satellites gather the data that feeds into the global models to predict what's going to happen several days in advance.
Okay.
So an example would be Hurricane Irma.
Okay.
For Hurricane Irma, the geostationary was able to look and see where is the hurricane now, what's going on. But then the polar data was used. Well, where does it go? Does it strengthen? Does it weaken? Where's it going to be? So we can provide that warning to folks,
right,
and they can prepare.
So when you were getting that data from GOES 16, if I recall, I mean, you were getting data much faster than the older generation GOES satellites.
That's correct. 5 times faster,
okay,
with the ability to download it every minute if needed.
Now, how is that going to be different than the JPSS data that forecasters will receive?
So whereas the geostationary data is downloading every 5 minutes, the JPSS is orbiting the planet to get global observations, and that's what we need for weather prediction models. So it basically traverses the Earth or orbits 14 times a day, passing over the same spot twice a day, and then we download that data twice in orbit.
This is the second in the series, so it's the MPP, or was it Suomi?
So Suomi
and
NP was a demonstration project,
okay,
that we brought into operations in 2014 so that we would avoid a gap. And JPSS will be the first of the operational series, and it will be known as NOAA 20.
NOAA 20.
When it gets to operations.
So MPP was sort of bridged the gap between the older polar orbiting satellites with the next generation.
That's correct.
So this is kind of interesting. So all this data that's being collected, I mean, where is that going to for NOAA?
So a couple of places. We feed that into our models.
Okay.
And so those high-performance computers we have run the models so we can issue those forecasts.
Right.
But then it's also stored in our National Centers for Environmental Information so it can be looked at later.
So not just meteorologists and weather forecasts around the country or even around the globe gets access to that data, but also scientists who want to use it for maybe long-term predictions?
That's correct. So folks who want to do long-term climate studies can take a look at it later on. I will mention that it also goes to our international partners because weather is a global phenomenon.
Right.
And we actually get data from our European partners from their polar satellites as well. So it's a share so we can all provide that mission to protect lives and property.
Now you went back with Hurricane Irma, and as a public user who watches the Weather Channel and other weather organizations, now you always see these models on TV. You see the European model, the American model. They have all these different initials for these models. How does JPSS and even GOES, which models do they fit in with that data?
So all those models actually use this data.
Oh, okay.
They all rely upon this data. And we use that with some forecast expertise, like at the Hurricane Center, to issue an official forecast. And for Irma, you'll note that our forecasts were really good, and that basically 6 days in advance, the governor of Florida was able to issue a state of emergency to begin preparations before that storm made landfall.
I mean, that's got to make you feel pretty proud that we have a satellite that's up there that's capable of doing something like that.
Absolutely. Our job is to protect lives and property. And when our forecasts, our predictions have enough confidence that decision makers, emergency managers can make decisions several days in advance to protect their local communities, that really is what our mission is.
Well, Joe, thank you so much for joining us today. We learned a lot about how forecasters and meteorologists can be using the data. So coming up next, we're going to have Kevin Doherty, who is the project manager for Sirius FM6, which is NASA's instrument on JPSS.
Joining us now is Kevin Doherty for Series FM6. Kevin, great to have you on the show.
Great to be here.
And I want to start right away. What is Ceres exactly? Because it's different from JPSS-1.
It is. So Ceres stands for Clouds and the Earth's Radiant Energy System. We're actually trying to study the energy balance in the atmosphere or in the entire Earth. So the Earth receives a lot of energy from the sun, and as it absorbs the energy, it then reflects some of it immediately, and it emits some other radiation, some longer wave radiation at nighttime.
Now, was there any difficulty for your instrument in terms of writing on JPSS-1? I mean, you're not in competition with them. They gave you a big window for you to get your data?
No, we're not in competition at all. In fact, we actually, as part of our data processing, use a lot of the information from some of the other instruments. So it's great to be on the same ride with them. And actually, in fact, on NPP, the predecessor, we were with some of the same instruments, and it's proven to be a very valuable cooperation.
Oh, that's serendipitous to have that kind of complementary relationship. Now, I'm wondering, this is FM6, which is Flight Model 6.
Yes.
What about the previous 5? Are they still in operation?
So there have actually been 6 previous ones, despite our number being number 6.
Okay.
The first one was a proto-flight model, and that was on trim, and that is no longer in operation. But Series FM 1 through 5 are still all up in flight. So we have 2 of them on the Terra spacecraft, 2 on Aqua, and 1 on NPP.
Okay, so that's great. Now, I understand that JPSS-1 is in a polar synchronous orbit. Wait, no, that's not right. Just polar
sun-synchronous.
Sun-synchronous, but polar orbit. Was that a mission parameter, and all the other Ceres instruments flying in a similar orbit?
It is. So all of the Ceres instruments are in what we call sun-synchronous orbit, which means that as the Earth rotates, or as the Earth goes around the sun, the orbit rotates as well. So the advantage that we get from that is that we can see both daytime and nighttime, but when we ascend over the equator, when we're passing over the equator, the spot on the Earth below us is always at the same time of day. So that gives us an advantage to see the Earth at the same time, see a little closer up than we would get from a geosynchronous or further away satellite.
I'm noticing this about scientists and collecting data at the right time and the similar time and building this continuous data record that they can look at. Is that a big part of what you're trying to do with Ceres?
It is a big part. And also on the NPP spacecraft, with JPSS-1, we're actually going to be on the complete opposite side of the Earth from NPP, so that we'll get a better coverage of the Earth as we move along.
Okay, so is this the last of the Ceres models, or are there more in the future?
So this is the last series in the series, but there is a
homonym.
follow-on coming up. There is a follow-on coming up called the Radiation Budget Instrument, where they are redesigning the technology to try to get an even more accurate measurement.
Well, good luck on the launch today. It's great to have you on the show. Hopefully, we'll be celebrating a launch here shortly.
All right, thank you.
Right now, we're going to go out to the pad with Tiffany Nail and Mick Woltman as they talk about this penultimate Delta II launch.
We are at the pad, and tower rollback is complete. That was phenomenal, Mick.
It was, Tiffany. This was a great day today. Beautiful California day. Tower roll just finished up about 25 minutes ago, exposing the Delta II vehicle to the environments, and she's a beaut.
She absolutely is. Mick, let's go through what entails a tower rollback.
So tower roll is a major milestone for us on the Delta II program. The launch team gets together and they start removing all the decks in the tower that are surrounding the vehicle as they prep to make sure nothing gets hit. Then they open up the doors on the tower, and then we start warming up the motors to get it ready to go. And then tower roll begins. It takes about 30 minutes to roll the tower back. But once it starts rolling and the Delta II starts coming out of the tower, looks really nice, especially today with this beautiful sunset here in California. That 7920 we have out there for JPSS-1 is just an awesome sight this evening.
It was really flawless.
It was. The team performed very well, and MST roll occurred just right on time.
Now let's talk about the Delta II. It is a 7920. Mick, what does that mean? Break that down for us.
So Delta II 7920-10C, which is what we are launching this evening for JPSS-1. It's a 7000 series Delta II with 9 solids, and what's unique about that is 6 of those solids are ground lit. So when we leave the pad this evening, we'll launch with the RS-27 main engine and 6 solids. And about 90 seconds into flight, we'll light the other 3 solids, which are considered our air-lit solids. And those are really nice. And, you know, this evening or early this morning when this launch occurs, it will be a beautiful sight to see all 9 solids come off the Delta II. The 2 in the 7920 stands for the AJ-10 engine that's on the second stage. And the Dash 10C that I mentioned, that's the 10-foot composite fairing that keeps the spacecraft encapsulated during ascent. I'm going to tell you what, the 7920 is one of my favorite Delta II configurations. It's probably one of the coolest things to see take off from the pad.
Talking about the Delta II, this is a bit historical for us, for NASA as an agency. This is our second to the last Delta II. So Delta II fans, jump on board, see the launch tomorrow, and then we have another one, right?
Yeah, we're referring to JPSS-1 as the penultimate, the second to last, like you mentioned, right? So NASA bought the last 4 Delta IIs that ULA offered up. We launched OCO-2 and SMAP on the first 2. Tonight, we're going to launch JPSS-1 on the third one, and then the 4th and final Delta II of this historic rocket will be in the fall of 2018, launching NASA's ISAT mission. And that'll be really nice. So I agree with you. If you want to see a Delta II, come on out this morning. I know it's an early morning, but it'll be a great show. And then again, the last one next year.
Then that's it.
Nope.
Now, Mick and I both work for the Launch Services Program, and we've been with LSP for quite some time. We've seen multiple Pegasus launches, Delta IIs, as well as Atlas V. I can't say, this is the closest I think I've been to a Delta II. But you know you have to see the spacecraft and you see the rocket. Mick, where do you see LSP?
Well, you know, going on with what you said, this is the coolest part of my job, being this close to a rocket. It's awesome. But you know what I really enjoy is being part of the LSP family. And what I see, a launch services program is an integral part of the NASA agency. We bring our scientific spacecraft customers together with our launch vehicle contractors. So we integrate them. We help them get together. Like tonight, we chose the Delta II launch vehicle for the JPSS-1 satellite to get it to the proper orbit and ensure mission success. Our engineers and analysts within Launch Services Program are a key part of making sure mission success happens for NASA.
We have a good substantial team here from Kennedy Space Center because we all reside in Kennedy, but we have resident offices throughout the United States. Let's talk about that.
Yeah, absolutely. The team is not made up just in Kennedy Space Center, but we have folks here in Vandenberg, in Hawthorne, in Dulles, Virginia, in McGregor, and we're doing great. And you know, the thing is, the team comes together for a launch like this evening. JPSS-1 is exciting. It's going to be the primary spacecraft, but what's unique about this launch tonight too, Tiffany, is we've got some CubeSats on board, which are really cool research, allowing people to do things and move forward with that.
You know, space used to only be accessible to the scientists and the engineers building massive spacecrafts. Now, space is accessible to everyone. That goes from the universities to middle schools. Check out this promo, Small Satellites, Big Dreams.
9, 8, 7, 6.
When I was a child, I spoke as a child.
1. Let's stop.
I understood as a child. I thought as a child. If I put away my childish things, how would I have any fun?
And welcome back to NASA Edge. We're being joined now by Rex Engelhardt, who is the mission manager for Alana 14. How you doing, Rex?
Hi, I'm doing just fine, thank you.
Well, what did you think of this pretty cool promo?
I think that is great, and it's very accurate. There's kids getting excited about space through the Alana program.
What does Alana stand for?
Alana stands for I'm going to make sure I get it right because I'm new to the program here, but Educational Launch of Nano Satellites.
Very cool.
It's all about launching these small satellites that started with cell phones, and they're moving their way up. They're getting really sophisticated now.
And that's the cool thing about these CubeSats is that not just professionals, but university and high school students can get involved in this CubeSat business and launch a spacecraft into space.
Let me correct you a little bit. Grade school, middle school, junior high, high school, and on up to professionals. They're actually doing serious. There's actually studies now, or in fact one flying here that's looking at building the next generation weather satellite technology in a CubeSat format.
That's incredible. Let's talk about the CubeSats that are going to be going up on this Delta II launch vehicle tomorrow morning. very early, by the way, at 1:47 a.m. Pacific Standard Time. What are the 5 CubeSats going up?
We have, again, as you said, 5 CubeSats. Now, CubeSats come in different sizes. We have 1 unit, 2 unit, 3 unit, and then they go up to 12, 16, even bigger. But we have 5 satellites on here. What we have is 2 3U spacecraft, and then we have another carrier with 3 1U spacecraft in it. So there's 5.
All right.
And we have Buccaneer, which is a spacecraft built by the Australians that's flying out there and doing some science. They're going to be looking at photometry and outer atmospheric drag experiments. Then we have Murata, which is going to be looking at microwave radiometry technology acceleration CubeSat.
Wow.
And they're looking at enabling, that's the weather satellite. They're enabling some new technology, very miniaturized technology for CubeSat format weather satellites. And then we have, I'll make sure I got everybody together here. We have EagleSat, which is from the Embry-Riddle Aeronautical University, the Eagles, where the name came from. And they're going to measure the decay of a satellite's orbit over time. They're going to precisely track it with some GPS technology and keep track and see what the upper atmosphere and try to really start calibrating in to what that kind of technology does. And it's also got a technology, instead of using batteries, it's using a supercapacitor, which I don't think any satellite's done. And then we have MakerSat, which is from the Northwest Nazarene University, and they're experimenting with a technology of 3D printing the satellite. And the idea is that if this all works, that you can just take the little cards, the electrical cards that go in it, so you're carrying a fraction of the weight to space, and then you just upload the program, and the astronauts on the space station print out the satellite. And they can put the thing together in 5 minutes and throw it out the window.
Well, Rex, you know, the cool thing about these satellites is that even though they're small, as you said, they're 1U all the way up to 3U or however big they are, I mean, they're still packing a lot of important technology.
They are packing a lot of technology, and they're only packing more and more. The sophistication of these spacecraft is just going up. And we've got one other I wanted to mention to you, Rad Effects satellite, and they're looking at the radiation effects out in space and trying to use commercial-grade electronics in space and trying to see what they can withstand and whether they'll work.
So hopefully these students tonight, they're going to be launching their CubeSats, and will they be getting the data back right away?
Yes, they get them back pretty quick. I don't know, you know, each program's going to have a different amount of time for setting it up and calibrating on orbit. They're going to be here watching, and then they usually make them wait for a little bit after they get ejected. Then they turn them on, and then you start looking for data.
Well, Rex, so thank you for coming and joining our show to explain the 5 CubeSats. And it's a really cool program. I can't stress enough to university students out there, to even down to elementary school students, if you want to get a spacecraft up into space, this is the program to get started, isn't it?
This is it. We're ready to take them.
Well, I'll tell you what, Rex, this ends our show, but we're not done yet, because coming up at 1:15 a.m. Pacific Standard Time, we're going to have KSC's live launch commentary show, and NASA Edge will be a part of that broadcast. So stick around. You're watching NASA Edge.